Hello dear student, myself Sana Kashif Sheikh, Assistant Professor, Department of Computer Science, Abeda Inamda Senior College. Welcome back to the series of Database Management System. Today we are going to see Relational Database Design. Relational database design models information and data into a set of tables with rows and columns. Each row of a relation table represents a record. Each column represents an attribute of that data. The structured query language SQL is used to manipulate relational databases. For example, we have a table that is student relation. Attributes are name, roll number, phone number, address, and age. The instance of schema student has 5 tuples, that means 5 records are there. Tuple number 3 is Lakshman 33289. The phone number, address is Gurugram, and the age is 20. Correct? So the relation is called student. Attributes are names of the columns and records are tuples. Correct? Now properties of relation. Name of relation is distinct from all other relations. So it is not allowed that two relation or two tables can have similar name in one database. So all the tables have different names. Each relation cell contains exactly one atomic single value. So it is not allowed that one cell can contain two values. For example, if you want two phone numbers into one record, it is not allowed. Okay, you can put only one phone number. Correct? So that means two values are not allowed. Only one atomic single value can be present in one single cell. Each attribute contains a distinct name. So all the attributes are of distinct name. Okay. No two columns can have similar names. Tuple has no duplicate value. So each tuple have the unique value. Order of tuple can have different sequence. Okay. So we can insert our tuples, our records in any order. Next topic is functional dependency. Functional dependency or FD is a constraint that determines the relation of one attribute to another attribute in database. So attributes are nothing but columns, correct? So we can say that one attribute can be dependent on another attribute. So this is called as functional dependency. Functional dependency helps to maintain the quality of data in the database. It plays a vital role to find the difference between good and bad database design. So the functional dependency is very important. It decides your database is good or bad. So we have certain rules for functional dependency. First rule is reflexive rule. What it says, if X is a set of attribute and Y is subset of X, then X holds a value of Y. Correct? What it means, if X is set of attribute, okay, and Y is a subset of X, correct? So X will hold value from Y, correct? Why? Because Y is subset of X, correct? So X will have all the values which Y have because Y is a subset of X, correct? Next is augmentation rule. When X tends to Y holds and C is attribute set, then AC tends to BC also holds, or XC tends to YC also holds. That is adding attribute which do not change the basic dependencies. Okay. Next is transitivity rule. This rule is very much similar to the transitive rule in algebra. If X tends to Y holds and Y tends to Z holds, then X tends to Z also holds. X tends to Y is called as functionally that determines Y. Okay, so that means if X tends to Y holds and Y tends to Z holds, so X tends to Z also holds. This is called transitivity rule. Now again we have the secondary rules also. In secondary rule we have union rule. union rule is if A tends to B holds and A tends to C holds, then A tends to BC also holds. This is called as additivity rule also. Correct? So if A tends to B holds and A tends to C holds, then A tends to BC holds. Next is decomposition rule. This is opposite of union rule. If A tends to BC holds, then A tends to B and A tends to C hold. This is called projectivity rule. Okay, so this is the opposite of union rule. Next is pseudo transitivity rule. If A tends to B holds and CB tends to D holds, then AC tends to D holds. Okay, this is little bit difficult. If A tends to B holds and CB tends to D holds. Okay, so that means A have been gone. Here we have C to D, correct? CB to D. So then AC to D also holds. So here B are common, correct? A tends to B and CB tends to D. Here B is common, so we'll remove B and it is going to be AC tends to D. This is called pseudo transitivity rule. Okay, so these are the axioms or rules we can say. Okay, so depend on this rule we are going to find out the F closure. So in your exam this type of question can come. Consider a relation R where we have A, B, C, D having below mentioned functional dependencies. So these are our tuples. Okay, then we have A F equals to A tends to B, C tends to B, D tends to E and E tends to D. So we have to find out the functional dependencies based on this. Okay, now we need to calculate closure of attribute of relation R. The closure will be C. In functional dependency A tends to B, C holds. So that means and A tends C. So we need to calculate the closure of attribute of relation R. That means all the whatever tuples are present, whatever records are present there, whatever columns are present there, we have to find out the closure of that. So A plus means closure of A. So there are A tends to B and A tends to C, correct? A tends to B, C. So closure of A is A, B and C. Okay. Now next is B closure. Now there is no relation where we are going from B to any tuple. Okay, so that means the closure of B is only B. Next is C. So we have C tends to B. So closure of C can be B comma C. Next is D. We have D tends to E. That means closure of D can be D comma E. And next we have E. Okay, now E tends to D is there, correct? So we have closure of E as E and it should be uh, D also there. Okay, so here we have closure of F.